Welcome again to another video for the same lesson, Chapter 5, Lesson 4, Sum and Difference Identities. Just to remind you of the objectives of this lesson, which are evaluating trigonometric functions using sum and difference identities, solving trigonometric equations using sum and difference identities. In the previous video, we stopped at this point. I gave you those two examples to try to solve them by yourselves. Cosine 15 degrees. So what's the answer for cosine 15? We said that we rewrite 15 in terms of two other angles such that they are part of this quadratic or this unit circle. 15 is simply 45 minus 30. Okay. And now you have cosine A minus B. Cosine A minus B is cosine plus, we change the sign here, plus sine. And you plug in 45, 30, 45, 30. Okay, the answer for this is radical 6 plus radical 2 over 4. Okay, for this one, 5 pi by 12 in degrees is 75. And now think of 75. How can you rewrite it in terms of two angles, sum or difference? We can say 75 is 45 plus 30 here's sine. We can write as sine of difference of two angles, 120 minus 45. 120 is here, 45 is here, but here I have sine A minus B, here I have sine A plus B. So you can choose any one. Okay, and the final answer would be radical 6 plus radical 2 over 4. The same answer as this, because 15 and 75 are complementary angles. Okay. Now we continue with the lesson, and we move on to example number 3. In example number 3, we have to rewrite as a single trigonometric expression. This one, tan 32 plus tan 13 over 1 minus tan 32 degrees times tan 13 degrees. How can I write this as a single expression, or how can I find a value for this? As you notice here, that this is like the other end of the sum identity for tan. You are given this part of the equation, tan plus tan over 1 minus tan times tan, right? So this can be simply written as the tan of A plus B, tan 32 degrees plus 13 degrees. We can add those two angles, those two numbers. This will be tan 45. Tan 45 you can evaluate from the unit circle, not directly, but we know that tan is y over x, or sine over cosine, sine and cosine for 45. For 45, sine and cosine are the same, radical 2 over 2 over radical 2 over 2, and this is equal to 1. Okay, so the value for this long expression is simply equal to 1. Let's take another example. You see how we simplify an expression. Here we cannot get a value, but we can simplify it. We have sine x sine 3x minus cosine x cosine 3x. So if you notice here in this example and the previous examples, we are kind of working backwards with those identities. We have the right hand side of the equation and we are going backwards. But here I have sine x, or sine cosine cosine. let me just grab this here and paste it here to make the comparison, for the comparison to be more clear. I have sine, sine, cosine, cosine. None of those start with sine, sine, cosine, cosine. But we have cosine, cosine minus sine, sine. Okay, so what can we do with this? Of course, I can reverse the order of those two expressions by simply taking a minus 1 common factor or minus common factor. When I take minus common factor, this would be cosine x cosine 3x minus sine x sine 3x. Now here I have cosine cosine, see, minus sine sine. So this is this part of the expression. This one here is the cosine a plus b. So minus cosine a plus b. A is x and b is 3x. Cosine x plus 3x is, we can add those numbers or variables. We have cosine 4x and the minus sign. Okay, and this is the simplified version of this long expression. All right. As a homework or a practice for you to do alone, find the exact value of cosine 7 pi by 8 cosine 5 pi by 24 plus sine 7 pi by 8 sine 5 pi over 24. Okay, here you have cosine, cosine, sine, sine. So see which identity fits here. And here we have to simplify tan 6x minus tan 7x over 1 plus tan 6x tan 7x. Okay, so try to do those as homework, and we're done with this video. Next time, or in the next video, we will discuss the last example in this lesson. Thank you very much.